We are taking R.D. Sharma Solutions, Class 10 Maths, Chapter 9, Exercise 9.4. Now, this is arithmetic progression exercise, but in different editions of book, it can be in different chapter. If 12th of an AP is 82 and 18th term, so 12th term is 82, 18th term is 124, find out the 24th term. So I'll give you a hint that how to write this 12th term. Always see the nth term is a plus n minus 1 into d. So whenever you have 12 term, it will be n minus 1, that is it will be a plus 12 minus 1 into d. So now on we will write directly a plus 12 minus 1 d is 11d. So whichever term is there, we'll just subtract one number and just write a plus subtracted 1 by this number and d. So the 12th of an AP is 82, so a plus 11d is 82, and 18th term, so a plus 17d, same logic, is 124. Now we have to find 24th term. So how to solve? Let us subtract these two equations. Minus, minus, minus. So a minus a, 17 minus 11 is 6d, and 124 minus 82. So what do you get? This is 2 and this is 4. So d is 7, 6 are 42. D is 7. Now put in any of these equations. Say I am putting it in the second equation. This is equation number 1, equation number 2. So I am putting it in the equation number 2. So what do we get? A plus 11 into d, that is 7, we found d, equal to 82. So A is, this is 77. So 82 minus 77. 82 minus 77 is what? It's 5. So A is 5 and D is the term which you got as 7. So D is 7. A and D is known. Now what will be the 24th term? Same logic, A plus 23D we have to find out. A is 5, 23 into D. D is what? 7. So this value will be 166. In an AP, the 24th term is twice the 10th term. Prove that this 72nd term is twice the 34th term. So it is given that the 24th term, so 24th term is twice the 10th term, so A10. What is 24th term? A plus 23d. And what is 10th term? A plus 9d. So what do you get? A plus 23d will be equal to 2a plus 18d. Now we have a relationship between them now, right? We have a relationship. Say a, let us bring it here, d term and a here. So 2a minus a is a, and 23 minus 18a is 5d. So a is 5d. We have to prove that 72nd term is twice the 34th term. So what is the 72 term? A plus 71d. We have to prove that it is twice the 34th term. So A plus 33d. Now what we will do, we will try to show that this holds if we put A equal to 5d. So let us put A equal to 5d plus 71d. This is twice. A is 5d plus 33d. What is this? 71 plus 5, it is 76d. And this is going to be 31 plus 5 is what? 36. And 36 into 2 is 70. 36 into 2 is, this is 76. So when these two are equal, that means we applied this. When we applied this, we got these two. Means this is actually twice of this, because left hand side and right hand side are equal. So hence proved. If the m plus 1th term of AP is twice the n plus 1th term of an AP, prove that 3m plus 1th term is twice that of m plus n plus 1th term. So first of all, we are given that this m plus 1th term is twice of n plus nth term. So a m plus 1 is given as twice of a n plus 1. So what is this a m plus 1? As I told you, a plus n minus 1 into d is the normal formula. So 1, we will subtract 1. So we will subtract 1, this will be A plus MD. And this will be twice of A plus ND. Okay. So we'll get an equation, relationship between A and D. So A plus MD equal to 2A plus 2ND. So bring A here and D term here. So A will be equal to 2A minus A is A, and this will be MD minus 2ND. So what do we get here? A equal to M minus 2N into D. Now let us use the second part, that is A, this 3M plus 1, 1th is what? A plus 3M minus 1 into D, that is 3MD. This will be equal to twice that, this one. So twice A plus, this is M plus N minus 1. So M plus N minus 1. So minus 1 will go, and this is equal to, this is D, right? So this is A plus 3MD. A plus 3MD equal to, this is 2A plus 2M plus N into D. Now we are putting the value A as M minus 2N to D. So A I am putting it as M minus 2N, D plus 3MD, and here 2 A I am putting as M minus 2N plus 2M plus N D. Now you see D is common. D is, if I put M minus 2N into D here in place of A, D is common everywhere. So I can just cancel out D everywhere. So this is M minus 2N plus 3M, and this is 2M and minus 4N, and this is 2N plus 2N. So what do we get? This is 3M and M is 4M minus 2N, and what is this? This is 2M plus 2M is 4M, and this is 2N minus 4N, that is 2N. So this both came as equal. When we use this and applied the previous one, the left hand side and right hand side become equal. So that is how it is proved. If the nth term of an AP 975 is same as the nth term of AP this one, find N. So how to do this? See, what is the nth term of this AP? A plus N minus 1 into D. So what is A here? 9. So 9 plus N minus 1. What is D here? See, 7 minus 9, that is minus 2. What is the nth term here? A plus N minus 1 into D. So 15 is the first term. N minus 1 into D. What is D? 12 minus 15, that is minus 3. So this is the equation we need to solve for N. So what do we get here? 9. This is minus 2N plus 2 equal to 15 minus 3N plus 3. Okay. So bring, this is 9 plus 2 is 11 minus 2N, and this will be 15 plus 3, 18 minus 3N. Now let us bring 3N here and 11 here. So 3N minus 2N equal to 18 minus 11. So this N is going to be 7. So N is 7. The 7th value of this AP is equal to the 7th value of this. Find the 13th term from the end in the following AP. So how to do this? We have to start from the end, right? There are certain ways to do it. The best way is to see what is the common difference here. First one I am taking. 9 minus 4 is 5. So common difference is 5. What is the A? This A is 4. Common difference, and this we know. So we can use the direct formula as the last term minus N minus 1 into D, right? L minus N minus 1 into D, we can directly use. What is the L? L is the last term, which is 254, minus N minus 1 into D, so 13. 13 minus 1 is 12. What is D? D is 5. So this is going to be 194. This is how we have to find out. I'll take this one now, the second one. 3597 and 201. So I'll just use the formula directly. The 13th term will be L minus n minus 1 into D. What is the L? Last term. What is the last term? 201. N minus 1, so 13 minus 1 is 12. What is D? See, 5 minus 3 is 2, so it is 2. So 201 minus 24, and what is going to be? 177. Here also same thing we'll do. L minus n minus 1 into D. What is the L? 88. What is n minus 1? 13 minus 1 is 12. And what is D? 4 minus 1, that is 3. So 88 minus 36, this is going to be 52. So yes, this formula you can use directly. Now the fourth term of AP is 3 times the first term. So A4 is 3 times the first term. First term is what? A always. A plus A is the first term, D is the common difference. So A4 is A plus 3D equal to 3A. So what do you get? You take A here. So 3D will be equal to 2A. Right? So you can write A as 3 by 2D. Now the 7th term exceeds twice the 3rd term by 1. So 7th term exceeds twice the 3rd term, that is twice the third term by 1. So 1 we have taken already here. Or you can just say that 2A3 minus 1 is equal to A7. That is why it is exceeding, so we just subtracted 1. That is why A7 is equal to 1. A7 plus 1 is there. So what is this A7? A plus 6D, 1 is already there, equal to this 2A3. 2A3 is A plus 2D. This is 2A plus 4D. So 2A plus 4D. Now what we are doing here is, we are putting A equal to 3 by 2D here. A equal to 3 by 2D plus 6D plus 1 equal to 2A. A we have put in 3 by 2 D plus 4D, right? So we can solve D from here, and when you solve this, D is going to come as minus 2, and D is minus 2. A will be equal to 3 by 2 into minus 2. So A will be equal to minus 3. So A is minus 3, D is minus 2. What will be the AP? Minus 3. And then A plus D, that is minus 3 minus 2, that is minus 5. Now A plus 2D, minus 3 plus 2 into minus 2. So minus 3 minus 4, this is minus 7, like this. Calculate the 3rd term and the nth term of an AP whose 8th term and 13th term are this, 48 and 78. Calculate the 3rd term. So A3 needs to be found out, and the nth term of an AP whose 8th term and 13th term are given like this. So we'll start with the 13th word term. A plus 12D equal to 78. And what is 8th term? A plus 7D equal to 48. Why I started with this? Because I wanted this as the first equation so that I can subtract it. Just subtract it. A minus A is 0. 12 minus 7 is 735D. And here 78 minus 48 is 30. So D is 5, 6 is 30. So 6. D is 6. Now put in any of the equations. I am putting it here. 6 plus 7D equal to 48. 7D is going to be 48 minus 6 is 42. So D will be equal to 7, 6 is 42. So no. I have to put D as 6 here. So A plus 7D. 7 into D, 6 equal to 48. So this is 7, 6 is 42. 42 goes here. 48 minus 42 is 48 minus 42. So what do we get A as? A as 6. So A is 6 here. Now A is 6 and D is 6 and D is 5, 6 is 30. D is also 6. Right? So now what is the 3rd term? A plus 2D. So for this A is 6, 6 plus this is 6. Okay. There is a slight change here. I'm just changing it to 6. So just assume A to be 6. A plus 2D, 2 into 6. So 6 plus 6 to the 12, it is going to be 18, right? It is going to be 18. What is an? A plus n minus 1 into d. So 6 plus n minus 1 into 6. It is going to be 6 plus n, 6n minus 6. It is going to be 6n. Nth term is 6n and third term is 18. How many 3-digit numbers are divisible by 3? So 3-digit number, that means we need to have 3 digit. What is the first 3-digit number? 100. And what is the last 3-digit number? 999. Right? How many 3-digit number are divisible by 3? So we have to start with the number which is actually divisible by 3. 100 is not divisible by 3. So 102 is the number which is divisible by 3. And 999 is of course divisible by 3. So our series is 102 is the first term. Then we have 105 because 3 it is divisible by 3. So 3 difference is there. 108 and like this 999. So A is 102, L is 999. So A plus n minus 1 into D I will use. Nth term is 999. So A 102 plus n minus 1 into D, and we don't know, into D. D is what? 3 equal to 999. So when we solve for n, we get n equal to 300. This is the 300. There are 300 terms in this sequence. So this is the first part, and we'll be taking the other part in the next discussions. Till then, thank you so much. Take care of yourself.